Okay, so what is given in this problem? A beam AB weighing 1000 Newton is supported as shown in the figure. Assuming all the pulleys to be frictionless, that means smooth pulleys, find the support reaction at point A. Okay, so this is the support point. So just by observing this support, we can say the given support is the fixed support. So this is the wall, and this beam AB is directly fixed into this wall. So this becomes the fixed support. Okay. Now for the fixed support, we know that there are three reactions. So if this is the beam and it is fixed with the wall, so whenever we draw the free body diagram, then it will have three reactions. So this is the vertical reaction VA, this is horizontal reaction HA, and there is one moment reaction, which is the MA. Okay. So first step will be we should draw the free body diagram for the beam AB. So you can draw that beam AB as it is. Now at point A, so this is your point A. So at point A, you will have VA, which is a vertical reaction. Then this is the HA, and there is one moment reaction like this. Okay. So right now we don't know what is the exact direction for this moment, whether it is anti-clockwise or clockwise. So just assume this to be anti-clockwise. Okay. So once we solve by using conditions of equilibrium, finally we will get the answer. Okay. So if that answer is positive for MA, then your assumed direction is correct. Okay. So after this, just observe the point load. So there is one point load given, which is 200 Newton. Okay. So point load has to be shown as it is. So it is acting somewhere here, and its direction is like this. So this point load, it is equal to 200 Newton, and its angle, this is equal to 60 degree. Okay. And this distance with respect to point A, it is 3 meter. After that, there is one pulley arrangement given, which is connected at point B. Okay. So that arrangement is like this. This is the pulley, and there is one weight. So I will just show the vector for 1000 Newton. And this is the rope which is passing over that pulley, and the rope is fixed at this point. Okay. Then there is another pulley like this. This pulley is fixed. And it is the same rope which is passing over the second pulley. And then here it is connected at this point with the beam. Okay, so this is the beam and this point is B. So because of 1000 Newton load or that dead weight, this rope will be subjected to tension. Okay, so we have to find out how much tension is developed in this rope. So this we can draw. Just assume if we cut the pulley, cut the rope, okay, then we can draw the free body diagram like this. So this is the pulley. On this pulley, we have the dead weight of 1000 Newton. Then on one side, this is the tension in this rope. will be like this. On other side, we will have the same tension because it is the same portion. So this is T and this is also T. Okay. So here you can use the equilibrium. So we can write 2T. So T plus T, this is equal to 1000 Newton. So from this you will get tension T is equal to 500 Newton. Okay. Now this tension, it will get transmitted from this rope up to the point B. Okay. And therefore point B will have the same tension in this direction. So T at the point B, we can show like this. This vector will be exactly vertical or it is along so it will be along this cable. Okay, so this is the T. And this T is equal to 500 Newton. Then at this point, which is a weight 250, so this arrangement is like this. This is one pulley. It is fixed like this. At this point, there is a weight of 250. And here we have another weight hanging, and this weight is 50 Newton. Now this weight, it is resting on the beam. Okay. So this weight 250 Newton, it will create one force on this beam. Okay. And it is not 250 Newton. So we need to subtract this 50 Newton from this 250 Newton so that you will get the net reaction on this beam. So if you draw two separate free body diagram, one for this weight and one for this beam. So here you will have one reaction which will be offered by this beam on that weight. So this reaction, let us take this as R. Okay. Then this weight, self weight is 250. And there is another weight which is 50 Newton. So that 50 Newton will create the tension in this direction. Okay. So this is the 50 Newton. So net reaction here R. So we can find out this reaction R plus 50 and minus 250. This is equal to 0. So R is equal to, this is minus 200. So it is plus 200. Okay, so net reaction R on the dead weight, this is 200 Newton. And it is the same reaction in the opposite direction when we consider the free body diagram for this beam. So similarly here, you can show that reaction like this, and this is equal to 200 Newton. So we have subtracted this 50 from this 250. So net weight acting on this beam in this direction, this is 250 minus 50. So it is 200 Newton. Okay. And after that, there is a UVL. So this is the UVL. So you can convert this UVL into point load like this. So this UVL you can convert like this. So net force or the point load, it will be acting at this point. Okay. So this value is 1 by 2. Height, that means intensity, which is 100, and total span. So this is equal to 6 meters. Okay. So it will act at this point. and this F is equal to 1 by 2, 100 into 6, so this is equal to 300 Newton. This point with respect to A, so it is equal to L by 3. So observe here, this is 90 degree. This total, this is L, that is equal to 6. So L by 3 means 6 by 3. So this is 2 meter. So this is equal to 2 meter up to this point. Okay. This total, this is equal to 3 meter. So we have shown all the forces. Okay. And after this, you can take the moment. So write the equation. So summation of moment by all the forces about the A, this is equal to 0. Okay. So you will start from this 500 Newton. So 500 and total distance of 500 is 6 plus 6, 12 meter. And this moment is anti-clockwise. So it will be like this. So don't show this direction. It is just for understanding. Okay. So this is positive. Then moment by this 200. So distance 200. So this is equal to 8. And this moment will be clockwise. So it is negative. Then we have to resolve this 200 Newton because it is inclined at 60 degree. So after resolution, you will get 200 cos 60. So its moment is 0 because this 200 cos 60, it will pass through the point B. There is no perpendicular distance. But this 200 sin 60, it is having the perpendicular distance 3 meter. So your moment will be 200 sin 60 into distance 3 meter. And this moment is clockwise, so it is negative. After that, we have 300 Newton into distance is 2 meter and moment is positive because it is anti-clockwise. And plus, we have to add this moment reaction, which is a MA. Okay. So plus MA. I have taken this plus because we have considered this to be anti-clockwise. If you consider this clockwise, we have to take this minus. So right now it is plus only, and this is equal to 0. This 200 sin 60 into 3, it is negative because the moment is clockwise. And calculate the value of MA. Okay. So if the MA is positive, that means your assumed direction is correct. Moment is anti-clockwise only. And if it is negative, that means you need to change the direction, that is the assumed direction, and actual moment is clockwise at the point A. Okay, so after this, you can use the summation fx0 and summation fy0. Okay. Okay, so note down this next problem. So this problem is on the sphere and the rod. So here one cylinder weighing 1000 Newton. Okay, just we made one mistake in this problem. We have not taken the weight 1000 Newton. So the beam AB is having the weight 1000 Newton. Okay, so we need to add this weight. So this weight 1000 Newton for the beam AB, it will act from its center of gravity. Okay, so the center of gravity of the rod AB will be exactly at its center. So if this is the rod AB or the beam AB, okay, its total length, this is 12 meter. So 1000 Newton will act from 6 meter. So this is the 1000 Newton. So we have to consider that 1000 Newton. So this is 1000 Newton and distance is 6 meter. Okay. So we need to consider the moment by 1000 Newton. So I will write here ma and minus 1000 into moment will be negative because the moment is clockwise by 1000 Newton and distance is 6 meter or perpendicular distance. So this is minus 1000 into 6. And now calculate the value of n. Okay. Okay, now refer the next problem. A cylinder weighing 1000 Newton and 1.5 meter diameter is supported by the beam AB of length 6 meter. So AB is 6 meter. Weight is 400 Newton. So for the beam, weight is 400. And neglecting the friction at the surface of contact of the cylinder, determine the wall reaction at D, hinge reaction at A, and the tension in the cable BC. Okay. So this is the given diagram. So I have drawn it here. So at the point A, this is the hinge point. Then this sphere, it is supported at this point. So this point is given as a P. B is the cable connected point. And here we have point C. Okay. So just neglect this distance. Okay, just consider point A is exactly in contact with the wall. Okay, so this distance is negligible. So here I have shown directly the hinge point exactly in contact with the wall. So this is the point A. At this point, this is the D, that is the contact of wall with this cylinder. And this cylinder is having the weight. So this weight, this is equal to 1000 Newton. Okay, and its diameter is 1.5. So for the cylinder, its diameter is 1.5 and weight is 1000. So question is we have to find out reaction RD, then reaction at hinge point. So we have to find out VA, HA, these are the two reactions, and the tension in the cable BC. So these are the unknown values. Okay, so to solve this problem, your first step will be we should draw the free body diagram. Okay, so for the free body diagram, you need to isolate the sphere from the rod. Okay, so we will draw two separate free body diagram, one for this sphere or the cylinder and one for the rod AB. Okay, so here we have drawn the separate diagram for sphere and rod. Now this point, it is the hinge point. So this is point A, this is the point B, and this is the contact point, which is a P. Okay, this point is the point D. So as we have isolated the sphere from the rod, then we need to show the reaction at this contact point. So here reaction is common. So the reaction will be like this. So this reaction is a RP. Okay. So it is the same reaction for the point P. Just direction is opposite. Okay. Now this RP reaction on the beam AB, it is a perpendicular. So this is exactly 90 degree. And this reaction Rp for this sphere or the cylinder, it will pass through the center point. Similarly, reaction Rt will be like this, exactly horizontal, because that reaction will be perpendicular to this wall and therefore it is horizontal. So this is the reaction Rd. It will also pass through the center point. Okay, and the weight will act in the downward direction like this. So this weight is 1000 Newton. Okay, so this is the free body diagram for the cylinder, and here for the rod AB, A is the hinge point. So this is the vertical reaction VA. This is horizontal reaction HA. Then at point B, we have this cable BC. So there will be tension like this. So this is the tension in the cable BC. Okay. Now for this tension, we have to find out its angle with respect to this horizontal. So the angle is not given. So we can find out like this. You can observe here, this is 45 degree. So if you draw this horizontal line, this is 45. So this angle will be same. This is 45. Okay. This angle is given in the problem. This is 60 degree. So 60, 45. So this remaining angle, this is 75. Let's check the calculation. So the 75 degree, it is the angle of BC with the AB. Okay. But we want the angle of BC with the x-axis. So you can refer this diagram. This angle is given as a 45 degree. Okay. And therefore, this angle, this is also 45. And this total angle is 75. So remaining angle will be 75 minus 45. So this is equal to 30 degree. So tension BC, its angle is 30 degree with this rod A. Now here we need to find out the angle of reaction RP. Okay, with the x-axis. So it is not given in the problem. So just I will draw one horizontal line. So we need to find out this angle. Okay, so you can find out this angle from this given diagram. So you can observe here, this angle is 45 degree. Okay, so this angle will be 45 degree because this is 90, and therefore this angle, it will be 45 degree. So here in the diagram, reaction RP is having the angle 45 degree with the x-axis. Okay, now you can consider the free body diagram for the cylinder first and use the condition of equilibrium, or you can use Lamin's theorem. Okay, so I will show how to solve this by using Lamin's theorem. So actually reaction RD is acting at this point. We can shift this at the center. So you can observe here. You can show the reaction RD. Then you can shift reaction RP directly at the center. So this is the reaction RP. Okay. So now observe the angle. This is 45 degree. So if you extend this line of action, so if this is 45 degree, this will be same. So this is 45 degree. Okay. So this total angle, it is 90 plus 45. So this is 135 degree. This is 90 degree. And this remaining angle will be 360 minus 135 minus 90. So this is also 135. Okay. Now you use Lamin's theorem. So your equation will be reaction Rp upon sine 90. This is equal to 1000 upon sine 135. That is the sine of opposite angle, and reaction Rd upon sine 135. Okay. So consider any two equations, Rp and 1000 and Rd and 1000, and get the value of reaction Rp and Rd. Okay, so from this equation, you will get reaction Rp and reaction Rd. Now to find out the tension BC, we have to consider the free body diagram for the beam AB. Okay, so for the beam AB, we have shown the reaction at point A, HAVA, then common reaction Rp and tension BC. One force is remaining, that is the weight of the rod AB. Okay, so that weight we have to consider exactly at the center. So let us take this is the center point, that is the center of gravity. Total weight will act in the downward direction, vertically downward. So this is equal to 1000 Newton. Okay, that weight is 400 Newton. Okay, so it will act exactly in downward direction. Now you can take the moment about the point A. Okay, and from this you can find out the tension BC. So first we will find out the reaction Rp, and after that consider free body diagram for AB, and then take the moment about A. Okay, so while taking the moment about A, we don't have this distance of point P with respect to point A. So that we have to find out from this diagram. So observe here, this is A point, this is the point P. We need to find out AP distance. So you can draw one line like this. Okay, so actually this line, it will bisect this total angle. Total angle is 45 degree because this is 45. So this is 22.5. Okay, and now you can consider this triangle. This is A, this is let us take this to be M, and this is P. So this is 90 degree. This is 22.5. We need AP distance. Distance MP is known. It is a radius. So diameter is given in the problem. This is a 1.5. So radius will be 0.75. So use tan theta. Tan 22.5. This is equal to 0.75 upon distance AP. So you can find out the distance AP directly. Okay. So AP is the perpendicular distance while taking the moment by the reaction RP. Okay. Then you can resolve the force tension BC. So you have to find out this component, then this component. Okay. And then take the moment about A. So for this component, tension BC. sine 30, and this tension BC cos 30. Perpendicular distance is not given. Okay, so by observing the angle 45 degree and this total distance AB, find out the perpendicular distance. So first extend this line and extend this line. So this is perpendicular distance for this component. So let us take this n. So AN is the perpendicular distance for y component, and this Bn is the perpendicular distance for this x component. Okay. Similarly, for this 400 Newton, distance is not given. So extend this. So let us take this point Q. Okay. So AQ is the perpendicular distance for this 400 Newton. So how you can find out this? G is the center of gravity. So AG, consider this triangle. This is A, this is G, and this is your Q point, and this is the force, which is 400. So AQ is the perpendicular distance. This is 45 degree, and AG, this is equal to total AB 6 meter. So AG will be 3 meter. So it is 3 cos 45. This is 3 cos 45. Similarly, find out AN. So this is 6 cos 45. This is 6 sin 45. Okay. And then write the equation summation of moment by all the forces about A. This is equal to 0. From this single equation, you can find out the tension BC. Okay. After that, to find out HA and VA, use summation Fx summation F1. Okay. So in this way, you can find out unknown values. So try to complete this problem.